Buildpacks. Right. Okay. Well, hi, everyone. Thank you for coming to this session. I'm going to be talking today about something called Buildpacks. Anybody here familiar with Buildpacks? Have you used this before? A few people? OK. So for those who know it, probably this is going to be very basic. The whole point of this talk is to be like an introduction. I realized very quickly that when I proposed the talk that I cannot actually fit the content in 50 minutes. It's way too much time. So what I wanted to do is give you bonus content. So I want to talk about something else in adjacent to Buildpacks itself, which is more security related in the space of containers. But considering now that neither of my demos are working, we'll have to figure this out. So before I get going, I want to make a disclaimer. Buildpacks is not a Google Cloud tool. We don't sell it. We use it in some of our products, but it's not the main thing that makes money for us, right? So consider this more as somebody who is enthusiastic about containers, telling you how I found Buildpacks, started using it, and sort of fall in love, OK? I'm going to be using Google Cloud products to do the demo, but I'm not trying to sell you anything, which means that even for Buildpacks itself, for the tool itself, if you end up finding yourself wondering, like, that's not good because I am using Docker and Docker is so awesome, that's fine because Buildpacks is not a silver bullet. It doesn't solve all the problems. It's good and useful for certain people, for certain use cases. It's not the solution for everything, right? Does that sound good? OK, let's get going. So my name is Abdel. I'm a cloud developer advocate at Google Cloud, actually based here in Sweden, in Stockholm. My background is in software engineering and infrastructure, but I've been getting into the world of Kubernetes and containers in the last 5 years. And I have worked with a lot of our customers that are, like most of the projects I worked on were really customers that are not in cloud and that does not use containers or does not use any container orchestration. I would say 90% of the use cases I worked on were these. I did work with customers who were like very advanced, that they're using cloud and containers and stuff. But those are compared or opposite to what some people might want you to think, the rare thing. Like people who are in cloud are kind of rarest than people are running stuff on-prem for various reasons. And one of the things I came across very often is this friction when you talk to developers who are used to do things a certain way, because developers are very protective. They like their tools, and they just want to use their tools. And they find it very hard to give away the tools to use something else. Very simple example. How many people here use Windows? How many people here have made a comment about people using Windows? There you go. See? So how many people here use Mac? How many people have made comments about those using Mac? There you go. See, my point is that we like to use the things we like to use because we are familiar with them. We used them before. And also because it's hard to learn new stuff, right? It's hard to learn new tools. Even if you're a developer and you do it with patience, you're probably thinking about your job as something you do during 8 hours, and then you're working on your side project or you're doing some competitive programming on the side, right? So Buildpacks, I came across Buildpacks a few years back, starting from Jib, which is, I'm going to talk a little bit about Jib. But I came across Buildpack, and it turns out it was a very useful tool to allow those who have never written containers before to actually start using containers just to get an idea of what containers are without the hurdle of learning Docker, right? Docker is a great tool, don't get me wrong. Writing Docker files is, in my opinion, one of the most horrible things you can do. It's not very complicated from a technical point of view. You can easily go to Stack Overflow, find an app, find a Docker file, copy, paste, and you are done. That's what most developers do. Maintaining Docker files is terrible. Following best practices to actually write Docker files properly is hard. Running tools to make sure that you don't shoot yourself in the foot when you're writing Docker files is hard. If you want to write Docker files the proper way, you might need a linter, you might need a scanner, you might need to learn multi-stage build, whatever multi-stage build is. I have been doing it for a while. I still don't understand what it is. You might need to learn some basic stuff. You might need to learn that entrypoints is for whatever reason not the right thing to do. All these crazy things, right? So when I worked with people who have never used Docker or Dockerfile or containers in general, and you tell them, oh, if you want to be a cloud native, now you have to do containers. And then people go, but I'm doing my jar file. It works fine. And they're like, no, you have to do containers because it's cool. And then they go, OK, where do I go started? Well, go to docker.io and learn how to do Dockerfile. Come on. So what is Buildpacks? Containers are thought to solve all the problems. Do you think they do? Yeah, no one thinks that. Yeah, good. They don't. The reason why containers don't solve all the problems is, and this is just my kind of way of looking at it, in our field of software engineering and tech in general, every couple of years, a new technology shows up. And this technology, usually, what it does is just build an abstraction layer on top of some stuff that we used to do manually before, right? The issue with building abstraction layers is that, in theory, abstraction layers make things easy. In practice, they make things more complex. Because abstraction layers work very well when you don't get error messages and your business is running very well on whatever platform you're running on. But the moment you start having issues, the moment you start having bugs, the moment your boss is calling you at 3 a.m. in the morning, telling you your website is down, you're a dumb person, you need to fix it, that's where abstraction layers doesn't work, right? Because then you have to go deep and understand what this thing does. And that's essentially what Docker does. Docker is an abstraction layer on top of existing stuff in the Linux kernel. Things that most of us don't have to learn, most of us don't have to know, right? But the moment you start running into performance issues with your container, then suddenly you have to go learn how to tweak that Docker container, and then you have to learn the underlying stuff, and then you end up at 3 a.m. in the morning on the server doing ps.aux, trying to understand what processes are running there and stuff like that, right? There is one thing that I want to make very clear. It somehow doesn't seem like obvious to a lot of people. So if what I'm about to say seems obvious, please excuse me. If it doesn't, that's a good thing. Containers are two different things. They are a way to package applications, and they are also a way to run applications. And those are two different set of problems, right? Talking about the runtime part, the main thing containers promise is build once, run everywhere, right? You build a container, you end up with an image, and they're supposed to be able to run it everywhere. It's not always true. It's the gap between right now, well, for a while, there was a huge gap between Linux-based system and Windows-based systems. That gap is getting kind of smaller and smaller. And also for a while, there was a gap between building for x86 and building for ARM. That also gap is kind of getting smaller and smaller because now you can build what we call multi-architecture containers, which you can run anywhere, right? So the runtime part is pretty clear. We can understand it. We can say, OK, I have a container. I build it. It's a standard container using something called OCI, the Open Container Initiatives. Most container runtimes and container tools today standardized around a certain way of building and running the container, right? The build part is the difficult part. And the reason why it's difficult is because you as a developer, you're supposed, or at least in the Docker world, you're supposed to tell Docker what to do. That's what Dockerfile is, right? The set of instructions for how you will build your container. Now, if we can solve the problem of runtime by standardizing how we run containers everywhere and anywhere, on cloud, on-prem, etc., that's a good thing. But we remain with the build part, right? The kind of not so nice part. I was about to say a fancy word, but I'm not going to say it. We're recorded. So most of you are familiar with something like this. This is how you would start building your container, set of instructions to tell Docker what to do. Now, a very important question, which will determine how this talk goes. How many of you like writing Docker files? 3 people? 4 people? Can you show them their... No, I'm just kidding. Most of the people don't like to do this, right? This is not programming language. Like, what is even label? I put this, I searched Dockerfile, I looked in Google Images and I copy-pasted the image without really thinking too much about it. And then I just realized I have never used label. So I don't know what it is. Sorry?
I have never used it either.
I had no idea. So whatever, copy from the internet, right? So Docker files are the standard way you would use to build a Docker image, right? You can think about it as a script. It's a set of instructions. It's flexible, which means it's powerful because it allows you to do a lot of things the way you want to do them. But this flexibility is also the weakness. The flexibility means that you can pretty much do anything you want inside the Docker file. And the fact that you can do anything you want means that you can either do the right thing or you can do the wrong thing, right? It's sort of trying to keep, like, it's a consistent way of building Docker files if you follow certain best practices. And I'm going to get to those in a bit. But this is probably one of the most inconsistent ways of building a Docker file. Can somebody tell me why? So this is not this thing. First, I'm going to even point it. Line number 2, is not a good practice. Can somebody tell me why? Yes? It doesn't use the patch version? That's partially true. It actually points to a tag. But in Docker world, a tag can be changed, right? You can just take any image and tag it whatever you want. It's just a random label. If you follow best practices of Docker, you are supposed to put a SHA, an actual signature in there, right? You're supposed to put the actual ID that identify a specific container. And that's just one of these best practices that you have to follow in order to benefit from the consistency Docker give you. Because if you tag every single dependency using its SHA, its signature, then you will have a consistent build. Then you will ensure that if you run a container, or if you run Docker build twice on the same exact file, you will end up with the same exact result, the same exact thing. One of the main reasons why this is not a good thing is if I am a malicious user, and I am the one hosting HTTPD on my Docker hub, right? Well, I can appear to be nice. I can tag the images 2.4, and then I can just switch that image for an image that contains a backdoor and apply the same tag. And then next time somebody runs a Docker build on that tag, they will pull an image that contains a vulnerability, right? Make sense? If you want to follow some best practices, there are quite a lot of them. There are best practices in Docker.io documentation. The multi-stage build, the static versus dynamic part, all that nice things. There are even tools you can use to make sure you are following those best practices. But as I said earlier, if you go down the rabbit hole of starting to use tools to make sure that your Docker files follow the same practices, you will end up with a CI/CD pipeline that has 20 steps: linting, scanning, tagging, checking if you are doing the right thing, maybe your own custom logic that your security team asks you to do, whatever, and then your build takes minutes. And that's why Java, as one of the programming languages, notoriously decided we're not going to go down the Dockerfile path. We're going to have our own way of doing things. And they created this thing called Jib, right? How many people have used Jib before? One person. All right. So what is Jib? And this is the stage where if my demo doesn't work, then I am screwed. Let's see. Oh. Yes. OK. Good. I am in. Am I in here? Yes. Good. The God of demo is with me today. So let me show you real quick how this actually looks like. Close, close. Yeah. No. Open folder, data, code. OK, cool. I have my code. Good. Let me fire up my terminal. And do you see my terminal? Should I make it a little bit bigger? Bigger? How about now? Is good? Cool. So this is just a very basic Java app demo thingy. You will notice I don't have a Docker file anywhere there, right? I can, so let me go to the folder itself. I can just make sure that I'm not bullshitting you. Right? There is no Docker file, right? Good. OK, let's do something. Docker build -- tag image. Let's see if it will work. I've never tried this before. It's possible it will work, and then you'll make fun of me. Yeah, OK, it doesn't work, because there is no Docker file, right? So how does Jib work? Well, you just go to your POM file, and you add this little snippet here. So you're importing the Jib Maven plugin. This is the version I'm importing. I'm actually pulling the last version. It's not the last version, but it's version 3, because I'm going to build an image, and I'm going to push it to a container registry in Google Cloud. And in Google Cloud, we have two versions of the same container registry. We have something called Google Container Registry, and we have Artifacts Registry, which is the new one. And the new plugin supports the new container registry. It doesn't matter. Think about this as like a Docker hub, but hosted on a Google Cloud platform. It's just a standard container registry. So this is my project name. This is where the repository is, and this is what the name of my image is going to look like, right? And so all I have to do is, first of all, open my instructions files so I remember how to do this. And that's it. I just run a maven compile jib build. So what this thing will do, it will use jib behind the scene. It will pull all the dependencies from the pom.xml file, and it will build an image, and it will push it to my container registry in Europe North 1, which is in Finland, right? So let's see, hopefully this goes fast, and I don't have to wait for it.
And we see a warning about not using the specific image digest.
What is it? Yes, does not use the specific image digest. Good catch. I'm doing the wrong thing, obviously. So this should have built my image. Actually, just to make sure, I think I have already built it before and pushed it, just to make sure. I'm just going to add the thing I told you should not add, tag. And I'm going to go here and show you the container image itself. So it's pushing. So I'm just going to go log into my Google Cloud Console. And hopefully, this should just work. Artifact registry. It's coming. Yeah. And then I have my Jfokus here. And I have my jib file. And I just pushed new image. Actually, it tagged the existing image because I didn't change anything in the code. So jib has caching, so it knows that the new build I ran is on the same exact code, which I didn't change. So instead of building a double image, like building a new image and storing it, it just decided to tag the existing one. Now, I'm going to start with one of the things that Buildpacks is really bad at doing, creating small images. I told you I'm going to tell you the good, the bad, and the ugly. Notice how big is this image? 214 megabytes, right? So almost 1/4 of gigabits. Now, let's go to this new cool thing called Buildpacks. So Buildpacks, what it is, it's a tool that started as an effort inside Heroku, and then eventually they open sourced it. Then Pivotal started chiming in. They released one new version, and then Pivotal and Heroku got together, released version 3, and that version 3 was dedicated or was donated to the CNCF. So it's a cloud. The CNCF is the Cloud Native Compute Foundation. It's a CNCF sandbox project, right? Which is an effort of multiple companies. It's open source. It's written in Go, and the way it works is the following. Now let's see if my second demo works, right? So I demoed how we use the jib part. Now let's say I don't want that. I just want to use the pack part. I'm not actually gonna. So I'm just gonna do this. So it's as simple as doing pack build, and then you give it the URL. So what this thing will do, it will build the image, and it will put it on my local Docker registry. It's not going to push it. There is a way I can tell pack to build and push the image, but it will just put it initially, just build it and host it in my local host registry. So I will let it run because it's going to take some time. And this is actually the second downside of Buildpacks is that it takes more time. The first build is always going to be slow, especially if you use something like Java or, God forbids, Node.js. It's going to be extremely slow because it does some caching, but the first time you run it, there is no cache, so it's going to take some time, okay? How does it work? Well, Buildpacks has this concept of builders. So builders are actually, you can think about them as base images, but they contain stuff that is needed to build for that specific programming language. So a builder, in this case, contains usually 3 things. There is a buildpack.toml file. That's the instructions for buildpack. That's the steps that Buildpack has to follow to build the image. There is a build and detect binaries. So the detect binary will analyze the source code of your app, and it will realize, well, what is this thing? This is a Java app, so it will know how to use the proper tools. The build is the actual thing that will build your image. Then essentially the build command line will pull the base container image with all the tooling, right? And it will just do the actual thing, which is kind of similar to Docker build. So you can think about it as base image, which is the builder, but on steroids. It's a base image that contains all the tools needed for the tool to know what your programming language is, extract all the dependencies, and then build the image, right? So this have built my image. It's supposed to be in my local folder, which is obviously because I haven't changed anything in the app, it didn't do much. I could delete it. Let me do that. It's going to take a little bit of time, but we have time, so we can do this. So I'm just going to purge all my images, and then I will run the build again. And this is going to take a very long time. So I'll have to somehow progress through the demo, and then I'll go back and show it to you. Yeah, OK. Let's let it run. One of the cool things about Buildpacks, and in my opinion, one of the very cool features is this thing called rebase. So before I move to rebase, you remember I told you earlier that I'm going to say the good and the bad, right? I talked about the good with Buildpacks. Doesn't require Dockerfile. Anybody agrees that that's good? All right, a lot of people say thumbs up. OK, good. The bad thing is you're going to end up with a very big image. It's going to be gigabytes. And then it takes a lot of time, especially to build the initial cache, right? So if you are one of the developers who is a guru in Dockerfiles, this is probably not for you. If you have never written Dockerfiles in your life, this probably will be good, because then you can go from my app to my image in a few minutes, right? Cool. Now, one of the things that is very cool with Buildpacks, which I like, is this thing called rebase. So what rebase is, essentially, when you run the rebase command, it will go to the base image, and it will see if there is a new version of the base image. And that base image usually contains the operating system, the OS. So if there is a new compiler, if there is a new patch that have been applied, if there is anything new in the base image, it will update the layer, which is the base image, without rebuilding the app, right? Very important. It doesn't rebuild the app. It just like compiles that specific layer and then replace it. You know that a Dockerfile is just a bunch of layers. A Dockerfile is essentially, and maybe you would disagree with me, it's a zip file. It's an archive file. It's just an archive with structure. It's a zip file that has layers, and the layers are like put in that zip file in a specific order. You can decompile a Dockerfile if you want. If you have a Docker image, there are tools that you can run to unzip or unpack a Docker image, and it will dump all the files back to your file system, right? So essentially what rebase does, it just like wipes out a layer and replaces it, right? This is great for if you have vulnerabilities in your app, like you have a vulnerability and you want to patch it very quickly without having to rebuild the image, the image, because it takes time. Then rebase is a great way to go about it. So what is this thing good for? Well, if you're a developer on the left side, it's good if you're a beginner. You don't have to learn Dockerfile. It's good if you want to go quick and easy, quick and dirty. You know, you're doing a hackathon. You're just learning. You just found some really cool app on Stack Overflow, and you want to try it, and you don't want to spend time building a container image for it. If your laptop does not contain that latest Node.js command line needed to build this image, and I think I can say that I'm not the only one who have been in a situation where I found something, I wanted to build it, and then I realized I have to install 600 gigabytes of dependencies to do it, right? I'm not the only one? Yeah, OK, 2, 3, 5 people, good. So then you don't have to install those dependencies, and you can just go and build the image and get it up quickly. It's gonna get rid of Docker files, which no one likes. We have established that. We talked about rebuilding the layers, the rebase part. And very important thing, it actually builds unprivileged containers. It's one of the things that we talk about when we build containers so much. Do not put an image which contains a privileged user, but no one really does it. Like about 70%, I read a report recently, about 70% of the containers that exist in the cloud space have run as root, right? So this thing comes out of the box with unprivileged containers. So let's see. Oh, it's finished. OK, so Docker images. I have my Docker image here. Cool. So if you are a an ops, security, DevOps, DevSecOps, whatever we call it these days, it can actually allow you to inspect an image, right? The same way, if you use Docker inspect before, Buildpacks has an inspect tool. You can use inspect to inspect what the image, what the layers are. It allows you to patch an image very quickly. The rebase thing I talked about, that's actually pretty cool for security people. And it does a bunch of other things. I don't have to go through all of them. So let's see a few things that this image. So I showed you the image, right? I could run it if I want, just to show you that this is not like, I'm not doing bullshit here. Come on. No. Docker run and not this, just this. And hopefully my app will run. And yes, it is running, and I can go here and I can check my app. I am checking on the URL of my remote computer because it's running on my remote computer, and it's working, right? Just my app, it's there. If I want to, remember I told you earlier that when I built my image, it did not get pushed. So the image I was running is actually running locally. I will delete this one here because I haven't, I want to show that I can push it. So I can do a pack push, or pack -- publish to publish the image, or I can do the build and publishing in one command. So pack build -- publish, right? So that will build the image and then push it to my container registry remotely. This hopefully will take less time because the image already was built. But let me go back real quick to the slides. And so we do use actually Buildpacks in some of our products. Maybe you have used those before. If you have used Cloud Run, anybody here familiar with Cloud Run? Few people. Have you used the build from source function in Cloud Run? No? So Cloud Run is, how many people know Fargate? AWS Fargate, so it's our version of Fargate. It's like a kind of container runtime, container service. You build a container, you give it to us, and then we run it for you. With Buildpacks, you can just not even build the container. You can just start from your code source, run a command, and then we will build the container for you using Buildpacks and deploy it. I did prepare the demo earlier. I'm going to show it to you. I'm not going to show the entire thing because it takes like forever. But I'll show you our running app. This actual app I showed earlier, running built from source. It's used in a lot of tools. So this is how, so if you are using Google Cloud Run and you want to build an app and run it on Google Cloud Run without the Dockerfile, this is how you would do it with gcloud, which is our command line. You can just do gcloud run deploy -- source dot, and then that will just use Buildpacks behind the scene, build the image, and then push it to Cloud Run. OK, so this is finished. Let's look at it here. I'm going to refresh. I have my app back here, right? Now let's click on it, and click on it. And can somebody tell me what's wrong with this image? The size, 700 megabytes. It's almost 3 times the size of the previous image, right? So these are the downsides for you to know. Also, there are 72 vulnerabilities in this image, right? That's a lot of vulnerabilities. So the reason why there are a lot of vulnerabilities is because I used the default stuff. I did not specify my own builder. I did not specify versions. I did not do anything. Buildpacks has a way where you can build your own builder if you want. So you can build your own builder that uses your own custom-based image. This is actually a great way for, let's say you are a platform team. You work in a company where you are managing the base platform that all the developers are using to build stuff. And you want to allow them to build things without writing Docker files because, as again, we have established no one likes that. So what you can do is you can build custom builders, you can host them, and you can let people pick your own custom builders and use them to build the apps. And then you can control everything. You can control the versions, you can control the tools that go into the base, the builders, etc., etc. Make sense? All right. I'm kind of ahead of time, so let me show you one more thing. I showed earlier no, I didn't show the inspect. Actually, you can inspect an image if you want. So you can just do pack inspect, and it will inspect the image. This is sort of what it does. Basically, it tells you which builder have been used, what is the base image that have been used, which builder. This is the runtime. What are the dependencies that have been detected? Which processes? There is like a single process in the app, which is the web app. It gives you a bunch of information, right? I can also do things like I can get suggestions, so I can run pack builder suggest inside my code base, and it will suggest a bunch of builders. Because I did not specify a builder, it's built using the Google one, but it can also use like HeroQ, or you can use like some other stuff, right? Now, I'll show you the rebase thing. So I'm just gonna run rebase on the same image, and what it's gonna do is it's gonna inspect every single layer, and it will see if the base layers, the base images that have been used to build the image, if there are actually new versions or new stacks. It's downloading stuff, so obviously it is finding something new, and it will just patch the image in place without having to rebuild it. Make sense? And we'll let that run for a while. And last thing I want to show you, and then I will stop for questions, not pictures. I will stop for questions, and then if there is more time, we can show you some other stuff which are not related to Buildpacks, but I think they're cool. So I have run this command before. On the same exact folder with the same exact code, I just did like a gcloud run deploy demo. So I'm just gonna deploy an app on Google Cloud Run in Finland, in Europe North 1, and I have deployed this before because again this takes forever. But if I go to my Cloud Run service here, I have an app running there. It's coming, hopefully, here. Demo Java app. And then if I click on it, it's my app. It's running on Google Cloud Run. So I went from source code on a repository that I just git cloned from the internet into running something on Google Cloud Run without really having to write Docker files, without having to care too much about how it works. All right, that's my app. So I'm going to pause here if there are any questions. There are a bunch of YAML files, okay, whatever. A bunch of slides I didn't show. That's fine. Any questions? Yes, yes.
You mentioned several times that there is a size issue. If you use those specific builders, do you get around the size issue also?
If you use your own builders, you can customize the size, yes. Yes. There was another question in the back? Yes, but it will take forever to build. So yes, it does, but it will take forever to build. You can actually, using the configuration file, there is a configuration file you can write using that .toml, and then you can ignore certain things. So you could like write a kind of a sort of git ignore or docker ignore to ignore certain parts of the monorepo, if that's something that you want to do. But it would work against the monorepo, yes.
With multiple languages?
It will build multiple images, actually. Yes. Yes. Sorry, come again? You mean pulling from your own repositories? Yeah, then you have to do your own builder. Then you have to build your own builder, which is based on the custom repos. Any other questions? No? OK. I have some time. And because I knew I'm going to be done before the 50 minutes, I'm going to show you one more thing. And this is because I love security. It's one of my favorite topics. And I think that what I'm going to show you is something that all of you can use. So let's start with the question. How many people here signed their images before they deployed them? 1, 2, OK. 3 people? OK. How many people here know what sign-in means? OK. Why are you're not doing it? Basic? I'm lazy. Ah, you're lazy. OK. I thought you said it's basic. I was about to say if it's basic, just do it. OK, you're lazy. Good. Any other better answer? Yes?
Because we're pushing to an air-gapped environment, and it doesn't allow custom signed containers.
You're running into somebody else's environment.
Well, we're pushing to an air-gapped environment.
Air-gapped environment, yeah?
It doesn't support your own signed containers. You have to, it only supports the ones that are officially signed on DockerFile.
Aha. So it does support signed images, but as long as they're signed from Docker Hub?
Yeah, we cannot push a signed image to it.
But it will pull an image from Docker Hub if it's signed. Yes. But that doesn't make any sense. So they trust Docker Hub more than what you're doing? Yes. OK, good. That's what I'm trying to get into. You see why I'm asking this question? You see why it doesn't make any sense? They trust Docker Hub, but they don't trust you. That's kind of ironic. Anyway, anybody else? OK, so I'm going to show you one of my favorite tools that I discovered 2 weeks ago. And it's again, open source. I'm not selling anything here. It's a tool called Cosign. Have somebody used this before? One person. Okay, cosign. So cosign is a command line tool that allows you to sign images. And there is another tool that allows you to actually verify or ensure that before an image is deployed to Kubernetes and to a lot of Kubernetes installations are signed. All of these things is open source, right? Cosign is the result work of SigStor, which is a consortium. It's a group of companies that together are working on making sure that open source is secure, right? So they do a lot of things like Salsa, which is a framework for security for CI/CD pipelines. And then they do a bunch of tools. One of them is Cosign. I'm not going to bore you with details. I'm going to show you. So what I'm going to do is so Cosign supports a lot of keys. You can do your own self-signed key, like generate your own key pair, and then you can use that to sign the images. In my case, I'm just going to use KMS, Google Cloud KMS, which is the key management system. I have a key there, which is a cryptographic key, so it's like a public, like asymmetric key, and it's software-based. You can also do HSM if you have a hardware security module. You can also use the Unicode, the security keys. You can store a key there and use it to sign your image. Cosign supports all of them. Let me show you what I'm trying to not do or trying to protect myself from doing. I'm going to pull a Docker container from the internet. This is Nginx. I'm doing everything horrible here. No tagging, no SHA, pulling from Docker Hub, right? Sorry? Good? Yeah, okay, great. So what I want to do is I want to deploy it to Kubernetes. I have a Kubernetes cluster. We don't have to go into the details. I have nothing running there. So I'm just going to do kubectl. I'm going to tag it. So before I do that, I have my Nginx container here, right? So I'm going to tag it. And then I'm going to push it to my repository. I am just tagging the image and pushing it to a remote artifact registry, a remote repository. Because if I want to deploy on my Kubernetes cluster, which is on Google Cloud, the image has to be somewhere. It cannot be on my laptop. So this is going to push the image, and then it's going to grab the SHA, right? Good. Now, if I go here, and I go to repositories, and I go to containers. And I click, I have my Nginx, right? And it's there, it's running, it's stored. It has some vulnerabilities, only 87 of them. That's fine, 78, sorry. So I'm gonna go ahead and deploy it. Yeah, I'm gonna go ahead and deploy it. So let me show you that. Right? No, I'm not deploying it to the test namespace. I'm gonna take this image here and deploy it. So I'm just deploying the image which is stored in artifact registry, right? It's running. It's going to run eventually. Trust me. Okay, it's running now. Good. That's what I'm not supposed to be able to do, right? I just pulled an image from the internet and deployed it on my Kubernetes cluster. What can go wrong? So let's see how can we avoid this. What I can do is I can take that image and I can sign it using cosign. So cosign is a command line. It basically cosign sign. You have to give it a key. My key is in Google Cloud Storage, Google Cloud KMS. It supports all KMS, Azure, AWS. It's very cloud agnostic. And then which image? Boom. This will sign the image. And one of the things it will do, it will actually add the signature of the image as a metadata to the image itself. So the image and the signature are stored together in the container registry. So if I go back here, I have a new thing that I pushed. And this new thing is literally the signature here. Right? It's just a JSON payload. Now, I can also verify it. So I can run the cosign verify. And this will tell me that the cosign claim were validated, the signature was validated against the specified public key. So I know that my image is signed. And then one other thing I'm going to do is I have deployed a controller. So it's just like a little tool, like a little software that I have deployed inside my Kubernetes cluster, which can verify the signature of my image before it allowed the image to be deployed. So I'm going to create a policy. So this is a cluster image policy. This is in the name, and it says, verify all the images that they are signed with this key. And this is the key I use to sign my image, right? Now I have my policy in place. If I create a new namespace, and in order for the controller to actually work, I have to put a label on the namespace where I want the controller to verify the signatures. Again, if you're not familiar with Kubernetes terminologies, don't worry about it. This is just Kubernetes lingo. And I will attempt to deploy an unsigned image. So here what I'm doing, let me make this a little bit better for you to see. I am saying, deploy something, and the image I'm using is Nginx. This basically will try to pull Docker from the internet. And this should fail. It will tell me that my image is not signed, so it cannot be deployed, right? But I should be able to deploy the image that I have signed earlier, which is the image in my container registry. And that should work, right? Very simple. You have a single command line. You add it to sign an image, and then you use the controller to verify that the thing you're trying to deploy is signed. There are multiple controllers. There is one for Kubernetes, but there are also ways you can implement a controller-like thing on a VM or something like that. Questions? How many of you after this are convinced they should do it? All right, I managed to convert a few people. And that concludes my talk. Thank you very much. If you have any questions. I finished before the 5-minute sign. Good. Any questions? Yes?
Buildpack thingy.
Yes.
Is it, if you want to go in and do some, just, oh, this is perfect. I just want to do this little modification, like adding one file or something like that. Do I have to build a complete Buildpack of my own?
Builder, yeah, unfortunately. Yes. It's one of the downsides. Yes. Yes?
Is there support for build, Postman, stuff like that? Do you have to have Docker?
No, you don't need Docker. I forgot to tell that earlier. You don't need Docker. I have Docker because I'm doing other stuff, but you don't need Docker. Yeah. It produces an OCI compatible image. So pack, the command line, is OCI compliant.
So it's just the tool for building images?
Correct. It's not a runtime, no. I mean, but the image is OCI, so it can run on any OCI compliant runtime. So you can run it with Docker or Containerd or whatever.
But it must be some sort of runtime if it's doing a sort of build inside a container, or for creating the image from the build image.
You don't need a runtime to build images, right? The runtime is the actual thing that runs the image. You don't need that to build images.
So it's just, it does the simplifying.
Correct. Pretty much, yes. And a bunch of bash scripts. Because everybody likes bash scripts. So, any other questions? All right, you can find me on Twitter. And is anybody listening to the Kubernetes podcast by any chance? I'm going to be sad if I don't see hands. OK, one person, good. 2 people. All right, thank you very much, everyone.